If you're looking for a weekend project to sharpen your Python programming skills, a project that will look impressive on a portfolio or resume, but doesn't require a ton of effort, a project that's easy for other people to understand and get excited about, then I've got the perfect idea for you. Why not build a Rocket League bot? In this video series, I'm going to show you exactly how to get started with building your own Rocket League bots. And then I'm going to walk you step by step through how to write a simple boost stealing bot in Python. Hey, if we haven't met, my name's Ben, and this is Learn Code by Gaming, where I help you learn how to program by playing video games. If you follow this tutorial all the way to the end, you'll walk away having taken your first steps towards writing your own video game AI. And you'll have taken a peek at just what it takes to predict and coordinate movement in three-dimensional space. But don't be intimidated. Even absolute beginners will be able to follow along. Rocket League is one of my all-time favorite video games, so it's great to finally have a chance to dive into the world of Rocket League botting. There's a great programming community that's built RLBot, which is a framework that makes it really easy to get into botting for this game. So we'll be using RLBot throughout this tutorial. It's really impressive what they've been able to build, and so far it's been a joy to work with, so well done to them. RLBot really makes a complicated project like this accessible to programmers of any skill level. Even if the word tangent scares you a little bit, you can still get by. So to answer the first question I know you want to ask, no, you can't run your bot in online matches against other humans. Which is a little disappointing, I know, but you got to consider that some people would abuse something like that to farm items. So what you can do is you can play against your own bots in a private match, which we'll definitely be doing. Plus, the good news is, if you are feeling competitive, RLBot hosts bot-only tournaments regularly. They even stream these events on Twitch, and they're pretty entertaining to watch. So if you're hoping to work on your Rocket League bot long-term, and you want to see just how good you can make it, those tournaments are definitely the best outlet for you to prove just how good your bots can be. And I think that's all the preamble we need, so let's get right into it. I'm assuming most of you are already set up for Python development, but just in case you're not, the first thing you're going to need to do is install Python 3. And if you don't already have a code editor installed, I recommend installing VS Code. You can download Visual Studio Code for free. And if you don't already have Rocket League installed on your PC, you'll need to buy it from the Steam store. It normally goes for $20, but I've seen it on sale for as low as $5, so it's a pretty cheap game to pick up. If you've got all that, the next thing to do is go to rlbot.org to download RLBot. Just click the download link and use the recommended settings to install. If you have any trouble when installing RLBot, just watch their quick start video. That should help you through it. And once you've got it installed, go ahead and launch RLBot. This will take a few minutes to run the first time you install it, as it installs all the Python packages that you need. And also the first time you run it, you won't see all the bots available here that I have. To get them, go ahead and click on the plus sign and click Download Bot Pack, and that will get you all these bots from other bot creators. And once you get to this step, go ahead and launch a game with a couple of the default bots. I really liked Beast from the East, and we'll set it up against one of the Psionic default bots. And just start the match just to make sure everything installed correctly and is working properly. And as you're developing your bot, one thing that's going to make your life a lot easier is to run Rocket League in windowed mode, like I have it here. So to do that, go ahead and hit escape to bring up this options menu. Click on options, go to your video, and then in your Windows settings, set display mode to windowed, and then set your resolution to something that's just slightly smaller than the resolution on your monitor, and then click apply. This is going to allow you to more easily switch between the game and your code. And while I've got it open, why don't we talk about what Beast from the East is doing here a little bit. So you can see all these colored lines coming out from his car. These are all things that you can draw as a bot creator to help you debug what's going on inside the game. So one of the things that this bot does is you can see the red line. That red line is predicting the ball path, where the ball is going to go next. And the different lines, like the yellow one, is probably where the bot is headed towards, what its target is. And these sorts of things are helpful to debug your bot and figure out what's going on. One other feature that Beast from the East has is this text that's right next to the car, and that's describing what behavior, what maneuver it's trying to complete at the present moment. So you can see it's constantly switching between different objectives. And so to stop the match, I'm just going to hit escape to bring up the pause menu, go back over to RLBot, the GUI interface, and click stop. And you should see here in the console window that it's shutting down. So let's go ahead and start our own bot. To do that, go up to the top here and click on the plus button, and then select Start Your Own Bot. In here, just type the name of it. We're going to call ours Boost Hog. and select Python for the language. And what this is going to do is it's going to generate a bunch of files for us to get us started with our bot. So we can even just run our bot right away if we wanted to. To figure out where those files are located, you can click over to the right of your bot, and it shows you down below where the file path is for your bot files that were created. Or you can click this Show Files button, and that will open up all of your files. So next I'm going to open up VS Code and open this file in it. Going to open folder, select the Boost Hog bot that we just created. And now I can see all those files that were generated over here on the right in the source folder. That's going to be most of the Python that you're editing. In particular, this bot.py file is the base for your bot. I also want you to check out the bot config file. And this controls the name of your bot. You can also put in your developer name here and a short description of your bot. And then a link to your GitHub repository for your bot is also a good idea. And then open the appearance config file. And this controls the way that your bot looks. So all the colors, all the paint jobs, all the decals, wheels, etc. for your bot, both on the blue team and on the orange team. All of the item IDs for the appearance can be found in the RLBot wiki. So for example, if I go to this wiki page and say I want to use a different type of car, let's use this Roadhog XL. So I would just copy this ID number, and then back in the code for the car ID, I would just replace that with the car ID that I want. So I'll save that, and then I should be able to launch my bot and see it using that new car. And then sure enough, my bot's using the Roadhog car, and it's using all of the default logic for a bot, which when you first create a bot, the default logic is just to go towards the ball. And it's not going to boost or flip or do any of that sort of stuff. It's just going to constantly drive towards the ball. So still talking about the appearance here, the same thing applies to all these other ID numbers. If you look at the ID list in the wiki, you'll find not only the cars, but also wheels and all the other things you could want, like the boost and the antennas. And then the wiki also has a page called Bot Customization. And in here it explains how to use the item IDs, but also how to set up your colors. So for example, your team color ID for blue by default is 60. And that will correspond to row 6, item 0 here. So color 60 is this one. If you wanted like this purple color over here, you would put number 29. And then for your secondary color, you have more options. So use the grid down here to set your secondary color. And in the appearance config, that is the custom color ID is where you would put that. So now let's talk about the source code a little bit. So go ahead and open up your bot.py file. And in here is the code for your bot. So right at the top, you'll notice there's a class defined in here. Here it's called myBot by default, but the name of your bot class actually isn't important. You can name it whatever you want. The key is that it extends from base agent. And base agent is a class that you are importing from the Rocket League agents code. And this is the key element that lets the RLBot framework know that this is the bot code that it should run. So inside every one of your bots, you're going to have two key functions. The first is the initialize agent function. And this gets called once when your bot first starts up. So you can do any initialization kind of work in here. The second function is the getOutput function. And this function gets called every tick in the game. And you can see it gets information about the game in the form of a game tick packet. And then it's expecting you to return a simple controller state from this function. So ticks are a key concept in every video game. And a tick represents the state of the game at any single moment. And you've heard of tick rates before. Every game is going to run at a certain tick rate. You should think of ticks like a movie film. So if you've ever looked at film from a movie, it's actually just a bunch of still images that are run together 30, 60 times a second. The same thing applies to video games and ticks. It's actually just a series of individual snapshots of a moment of time, what the state of the game is, where all the players are, where the ball is on the field, all of that changes between each tick. So it's actually not continuous motion. It's just a series of discrete moments in time where the values, the state of your program is differing slightly between each tick. So the tick packet here is going to give us information each tick about what's going on inside the game. For RLBot and Rocket League, it is running at 60 ticks per second. So 60 times every second, you're going to get information about the state of the game. And in that small window of time, you have to do all your calculations and tell the game what the state of the controller should be for your bot at that point in time. And for the simple controller state, you should think of that just like the gamepad you're using to play the game. So I've got a PlayStation controller. Every tick you're going to want to return which buttons are being pressed and where the joysticks are. And that's all we need to do to tell the game what our bot should be doing. So let's talk through the code here. We're first getting the ball location, and that's going to be a vec3 class instance. So this is just a vector in 3 dimensions. And this is a class that's provided to you by default. You don't have to use it, but if you look in your util folder and open up the vec file, you can see this is where the vector3 class is defined. And this just makes it easy for you to keep track of the locations of different items in the game. And then you can do things like add them, subtract them, do different math operations on them. You can see all the different operations you have here to work with. And that's just going to make your vector math when you're doing your logic a lot easier. For your car inside the game, we're going to get that information from the packet. We're also going to isolate the car location, again, from the packet that we're giving. But we're going to wrap it in our vector3 class. And then to find the vector that goes from the car to the ball, we're simply going to subtract the ball location from the car location. We also want to know the orientation of our car, which way is pointed forward and which way is pointed backwards. So for this, we can look at the car rotation value, and we're going to wrap this in an orientation class, which again is another class that they give us by default with the code in the utility folder. So let's open up the orientation file. So here's where the orientation class is defined, and it's just keeping track of the yaw, roll, and pitch, and then it's calculating for us the forward, right, and up directions, those vectors based off of the orientation that we give it. And then from the car orientation, we can grab the direction, and then using the car to ball vector and the car direction, we're going to pass it to this function called find correction, and that's going to return whether our car should turn left or right to go towards the ball. So you can see here the steer correction radians. If it's greater than 0, we're going to turn left, and we're also going to display that outside of our car. Otherwise, we want to turn to the right. And these turn -1 and the number 1. It's going to be a full left turn and a full right turn. So imagine the joystick moved all the way to the left or all the way to the right. We're also going to set our throttle to full, and then we're going to steer in the direction that we want to turn. And so we set the throttle and the steer direction on our controller state, and that's what we're going to return from this function, because again, that's what we need to return from get output. We need to give it a controller state. We're also going to draw out some debug, and that's going to do 2 things. It's going to display next to our car whether we're turning left or turning right, and it's also going to draw a line from our car to the ball. Down below the class, you'll find our 2 helper functions. You have find correction, which is doing that math for us to tell us whether we're going to turn left or right. And then you also have the draw debug function, which is going to draw out that line from the car to the ball, and it's also going to draw a string next to the car about what direction we're turning. And that's really it as far as the default bot code that they give us to start with. And so in this tutorial, what we're going to do is, instead of having our bot chase after the ball, we're going to have it grab boosts instead. So we're going to find the nearest boost to our car, go grab it, and then do that again. So it's going to be a boost hog bot where it just does laps around the arena and grabs all the boosts possible. So to do that, what the logic is going to look like is, instead of determining the ball location and our car, we're going to find the boost locations from the game tick packet. There will be data in there about where the boosts are located on the field. We're going to look those up. We're going to do some math to compare it to our car location, find the nearest boost, and then once we find it, we're going to orient our car towards that boost, and we're going to drive towards the boost instead of driving towards the ball. So you can imagine in the code here, it's going to look very similar, except instead of where we have ball location, we're going to have the boost location. So then we just need to write a function to find the boost that we want to go towards. So I should mention that RLBot is really cool in that you can modify the code while the game is running, and it'll update inside the game. So you can be running the game here, and as your bot is performing its logic, you can actually go and update your code in here, and it'll update automatically. The one thing that you do need to stop the game and restart for is if you make any changes to your config files. After you make those changes, you will need to stop the match. It'll keep running, but you can pause it here. In your console window here, you'll see that it is shut down. And then after you make your config changes, you can just start your match again. No need to close down Rocket League or anything like that. It'll run faster if you don't. You'll also get scored on a lot by the Psionics bots if you're running it against your Boost Hog bot. So what I recommend doing instead is, when you're testing it out, just run your Boost Hog bot by itself. And so you can see as we run it here, it's perfectly fine just to have the one bot all by itself. Also, don't forget to set up your GitHub project for this bot, especially if you plan on using it in your portfolio. So then, if you think you can take it from here, definitely give it a shot, and let me know in the comments how it goes for you. Remember to subscribe to the channel if you like this sort of content and want to see more of it. And if you ever get stuck, or if you just want to compare your Boost Hog solution to mine, in the remainder of this tutorial series, I'll be talking about exactly how I built this bot. Or if you want to follow along with me, head on over to the next video, and we'll start writing code for our Boost Hog bot. See you there.